I'm Bill Hoffman, and I'm going to be talking about CMake. So, a little bit about me. I've had 2 real jobs in my career. I spent 9 years at GE Research. Spent my time there moving the research team in a computer vision group from symbolics list machines to C++, back when C++ was C-front, and Solaris, and later Linux and Windows. I was sort of the build guy, did CMake, auto tools, and some other stuff. In 1998, I left GE and was one of 5 founders of a company called Kitware. So I'm kind of either the Kitware guy, the CMake guy, or the sandal running guy these days. Mostly I'm the pointy-haired boss at Kitware and don't get to do much coding anymore. But you might wonder, what is a Kitware and what does it do? Some of you know, but a lot of people don't. So they figure that we must make a whole bunch of money off of this CMake. So we get $100 from everyone who makes CMake with our subscription model. ChatGPT says that's maybe $100 million a year. Kind of cool. So how do we spend this $100 million a year, or $100 billion of CMake revenue? Well, of course, we have about 500 senior developers in the U.S. and Europe, or maybe 1,000 developers across the world. But personally, I'd probably buy yachts and fancy cars with it all. But really, if we had all these CMake developers, they would fix any feature the users wanted, fix any issue reported within 24 hours, and the documentation would be perfect. We'd provide support to any question. Actually, Kitware is a consulting and research company that does work in computer vision, data analytics, scientific computing, medical imaging, and software solutions. And the team, the CMake-ish team, is actually a small team in the 200-person company. And where did this crazy CMake thing come from? You can thank the National Library of Medicine in the US for the original funding for this. Came from the ITK project. They wanted to create a C++ library to codify the state-of-the-art in segmentation and registration algorithms for medical data. And Kitware was one of 3 commercial companies on the contract, and there were 3 universities. And I was young and crazy and said, I'm going to write a new build system for C++. I remember pitching the idea to the ITK group, and this guy from CMU raised his hand, Bill, why are we creating an ITK build system? Can't we use something standard? And before he let me talk, he's, oh wait, you're talking about like writing a C++ build system for the world. I'm like, yes, world domination. And amazingly enough, CMake is like 25 years old now. I was 33. That's insane. So we look at, one of the main objectives of CMake was to not add external dependencies. So the only thing I wanted to depend on was a C++ compiler. Hence the language that came with it. And this, I like to call it back then the Easter egg hunt, which SPAC aims to solve as well. It was like, hey, I want to build this project. Well, build these 5 things first. And tried to solve that with the CMake project. So there's a really good talk that a guy from Kitware, Vito, gave at C++ Now last year, the errors of CMake. CMake 1, the primordial flag soup. CMake 2, world domination. CMake 3, I hope you like target star commands. And then we'll talk about what CMake 4 is. So the primordial flag soup, this was sort of 2000 to 2004. This was kind of the friends and family era. ITK, VTK, we infected the national labs with it through VTK, and a lot of you folks here were involved in that, and we were able to get some funding for that, and then there was the ITK funding, and we got a bunch of compiler flags, and we sort of passed them down the source tree, kind of like you used to do in Makefiles. And it looked something like this, where you said some source files didn't have extensions on them, which is kind of funny because 25 years later in CMake 4.0, we finally deprecated adding source files without their extensions, which actually added like a speed and performance, because if you gave it files, it always like searched. Oh yeah, and if you see the little veto thing, and these are slides I stole from his presentation. But also back then, we had find package. So we're thinking ahead. This is neat stuff. So CMake 2 was really the era of growth of CMake, where I was out there just trying to get anybody to use it that I could find. And I landed a big one. The KDE project, and this was huge, I think, for the whole community, because it's kind of solves the chicken and the egg problem, because it's like, oh, I don't want to install this CMake thing, it's not on my system. But by taking the most popular windowing environment for Linux and making it depend on CMake, suddenly CMake was on every Linux distribution, which has blessings and cursings. But yeah, that was really big for us. And it also improved the code a lot, because they needed better install. They needed shared library versioning, standard Linux install stuff. And like I said before, it's friends and family, and we just got by with what we had. And then we got CMake pre-installed everywhere. And then somewhere around this period, a lot of people started picking up, and we started getting really great contributions from the community. Modern CMake was born. I'll go into that a little bit. LLVM adopted CMake, and this is Google search trends down at the bottom, and you can see when KDE adopted it, suddenly everybody said, what is this CMake thing? There's a really good talk here that Stephen Kelly, he was a KDE developer back then, and the crux of modern CMake was, it shouldn't matter if when linking to a target, whether it's in my build tree or whether it's someone else built it and I pulled it in. The code should look the same. And that was sort of the birth of this target model in CMake. Really good talk if you want to go back and look at it. CMake 3, hope you like target star commands. This is where build requirements and usage requirements came into CMake, and the idea of interface libraries. Some random things I think that are cool in CMake. You can do performance testing of your CMake. I mean, this is before the other performance testing of the build stuff that I'll talk about. But if you have, let's say I write for some reason I have an execute process sleep 10 in my CMake code. I run profiling. I can visualize the data in Perfecto, and then I can see here that this execute process thing is taking half the time of my configure. And I can see it's on this line of CMake code. And this has all been in CMake 3, the ability to do this. So let's remove the sleep and we'll retry, and then we can see it's faster and looks more normal. In CMake 3, we also added the debugger DAP, debugger adapter protocol. So any editor that supports DAB can debug CMake code. I was able to pop up, like I said, pointy hair boss. I don't play around with this stuff much anymore, but I'm still using Emacs because I'm an old guy with the gray hairs. But I was able to load up Visual VS Code and run the debugger on CMake, in about 10 minutes, which is kind of cool. We added parallel install. This is a 3.31 feature that allows you to do install, which improved the install times on some projects dramatically. That was also one of the things that got improved for way back with KDE. The install was super slow because we used to copy everything, and then it had to change. It had to relink sometimes, and then we added the ability to change the RPaths during the install and made that a lot faster for them. But before moving on to CMake 4.0, I'm going to jump back in the Wayback Machine. Earliest CMake webpage, 2002. Here's the thing, that it's got some goals for CMake. We'll look at those and see how well we did. Side note, in 2002, we had C++ 98. The big new things were namespaces, bool, RTTI, and new style casting, and the STL. Yeah, and also the CMake list.txt. This is what was there, and it was to provide make files for Unix and workspaces for Visual Studio. Sort of sideline, I always thought that if Microsoft caught me back then, reverse engineering the Visual Studio formats and generating them, they might have sued me or something. And now they distribute CMake, and we have a monthly call with them, and it just blows my mind. This is kind of funny. Part of the development, is outstrip the documentation, because coders like to code, they don't like to write documentation. As a result, the best way to learn CMake is to look at existing CMake. Yeah, well, this was bad advice. If I could go open the Wayback Machine, I would get rid of this. So let's reflect on some goals here. Here were the goals I had originally listed on the web page. So develop an open source cross-platform tool to manage the build process. This was in 2021, Bryce Adelson. You want a standard CMake build system? You've got one. It's called CMake. Resistance is futile. So I'll give us an A++ on creating an open source cross-platform tool to manage the build process. Allow the use of native compilers and systems. Well, we can do, Visual Studio Code, Xcode, Ninja, Make, maybe something new someday, pretty much every compiler that's around. So again, I think I'd give us an A+ on that. Simplify the build process. Well, this is the annual C++ developer survey. Managing libraries that my application depends on. These are pain points. Managing CMake projects, setting up a development environment, managing make files. And all this goes to what we're trying to do in this room, right? Solving things with SPAC and CMake and making both of those tools solve these problems. But, I'd say we're still somewhere around a B or maybe a C. Maybe I'm being a little generous. Or maybe people just like to complain about it because they don't know how bad it really was back then. Optionally, provide a user interface to manage the build system. Well, we've got the ones we have. And Visual Studio Code has its own way of managing the CMake build. So again, I think we did pretty good with that. Create an extensible framework. Well, the CMake language is no one's favorite part of CMake. But some people have done some really weird things with it, like create a ray tracer. This actually works. I've run it in the CMake language. But yeah, I'd probably get a B on language choice and some of the choices made there. What's that? Yeah. It's not too bad, actually. It's faster than ray tracing was when I started computer science. So. Self-sustained community of software users and developers. I think this has gone well. There's 1,500 contributors. It's still around after 25 years. There's people writing books in it better than the ones we wrote. It's a great community, so I'd give us an A there. CMake 4. So implementing and defining formats for other applications can use. I think this is the direction we're going. We've got this big market penetration. Let's do something really good and helpful with it. CPS, the Common Package Specification, is a JSON that will be available to IDEs, package managers, and other tools to consume. I'll talk about it a little bit later. Modules and standard formats. We worked with the standards committee to get a standard way of specifying the dependency information for C++ 20 modules and creating module metadata for import std. And again, this stuff will be used in CPS. Back to this, look at and rely on existing CMake. Well, this has caused a lot of bad CMake out there in the world. And because of that, some people actually want to move from CMake 2 to CMake 4. And now there's a new feature in CMake that you can have an alternate name for a CMake list.txt. So like before, when you were moving from, say, AutoComp to CMake, it was easy to have CMake list file and your AutoComp files. But if you want to move from CMake to CMake, you couldn't do it. Now you can, because you can have CMake update.txt. and then specify it here. It's not meant as like a long-term thing, but a short-term thing so the two build systems can sit next to each other. And it always emits a warning. So it's not something like you can just change the name because you don't like the name. It's a useful tool for migrating. If you want to know what's cooking in CMake, there's the, if you look at master, help, dev, experimental, this lists all the features in CMake that are currently in experimental mode. The current experiments, there's a couple of them involving CPS, although the major feature of CPS just came out of experimental, which is really cool. Import stood is still in experimental. It briefly came out and then went back in due to some compiler issues. Build database support, a JSON file with build information for building modules. The software bill of materials is now in experimental. CMake can generate SBOMs, and there's some experimental Rust support. But this is really exciting to me. CPS is here and out of the experimental gate. There's a new blog that just came out today, I think. This was started in 2016 by Matthew Wolke. There was a 2018 WG21 paper, and then a talk at C++ Now by Brett and Daniel from Bloomberg. CPPCon hallway track with the Conan VC package folks, some others. And then 3 talks in 2023 CPPCon. And we're working on it in CMake. And there's some other talks. But the basic idea here is, even after all these years, 30 years of doing C++, I don't think we've really defined a binary library or a package in C++, at least in a machine. Everybody has a concept of what it is, right? Tell me what's a library. All right, well, it's a binary thing in disk, but okay, what do you need to use that? You need some include flags, maybe some -d flags, maybe some other compiler flags to use it. So this aims to provide a way of defining that in a machine-readable way. It's language and platform agnostic, tool agnostic, going beyond the CMake ecosystem. So CMake has a way of exporting targets, and they create .cmake files. We want to replace that with a JSON file that, something like SPAC could read, or other package managers. SPAC could produce it. CMake can now read it. And this is open source and being publicly developed. If you're interested in this, please join the community and help us out. You can have multiple configurations for a Giffen package, multiple components, flexible version compatibility, relocatable by default, transitive dependencies just work. So if you look at the old way in CMake, you'd install export targets, install the CMake config files. In the new way, you do install package info and then export the targets. And this is the cool part. To use it, it's the same thing. It's just find package. So it's not going to look any different than it used to. For usage, it'll just change in export. And we're hoping to integrate this. We've got some support for it in Conan and SPAC to both consume and export CPS files. If you want to contribute, there's the reference docs, there's a Slack channel, and a mailing list, and the ecosystem ISO discussions. The other big thing that's happened with C++ is modules. C++20 named modules are fully out of experimental in CMake. And then import stood. We're still having some issues, but we're getting close. So why do we care about modules in the build system? If anyone knows about Fortran modules, you'd know about this. So if I've got my A thing that exports module A, and then B that exports module B, but my A imports B. If I try to compile A, I'm going to get an error because it can't find B. But if I just compile B first and then compile A, everything's happy. So suddenly order matters because I've got to compile all the producers before they're consumers. So that means I need to parse the C++ before I parse the C++. Yikes. So we went to the standards committee and created a format for this and added flags to the compilers to do a dependency scanning step for modules. The way we did it in Fortran is there's actually a Fortran parser in CMake, which is horrible. We'd love to get rid of that, have the Fortran compilers actually do what we've done with the C++. Fortran's a little simpler to parse than C++, so we get away with it, but it still gets things wrong occasionally. In CMake, to use modules, you use file sets. So you create a file set, C++ modules. You put them in there. You can install them. Import stood. Unfortunately, had to get reverted back to experimental. It's almost there in these compilers. But the idea there is, you wouldn't have to worry about include what you use. It does work faster. It's a kind of cool exercise if you go in and see how it's implemented in Clang and Microsoft if you're interested in stuff. But it promises faster builds. Another new thing in CMake, there was a whole talk about this, is the CMake instrumentation, which is now in 4.3. If you're interested in this, it basically allows you to instrument the whole build process. And put callbacks so you could report back to a centralized system if you wanted, or you can send it up to C-. If you're really interested in this, I encourage you to watch the talk that was done at this conference by Martin. To enable it, you just call CMake instrumentation. You've got an API. You can set a callback. There's a couple other nuanced ways to set it up. You can do a .config file. You can tell CTest to use it with a simple flag. Another new cool thing in CMake is SBOM generation. I need to work with SPAC, so maybe we can coordinate a little bit. But essentially, the idea here is to add native support for SBOMs in CMake. I think if we, I think that the government kind of rolled back the SBOM requirement. Sort of, kind of. But I think one of the points they make, though, is we want people to, I think by putting it into the tools and making it so that it's not extra work, solves the problem, that the reason why they wanted to retract it. They don't want to add extra burden to people. I think these are useful things to have. And if we build them into the tools and they become just like breathing, then everyone will do it, and it'll be there, and it'll be better for the community. So this is actually being funded by a DARPA project. And right now it does SPDX. Another cool thing, we added a new generator in CMake. I always talk about, like, Ninja was one of the cool things I think that happened with CMake, in that, Google came out with this new tool, it was faster than Make, and I think within a month we had it in CMake. And then everybody that was using CMake suddenly got faster parallel builds. And they had to do absolutely nothing other than upgrade their CMake and add a -G Ninja. Same thing here. There's a new tool. This is really popular in the gaming community. It's called Fast Build. I'd say well, I've got some graphs coming up. Let's see. Yeah, so it does distributed builds sort of natively. So it's super easy. I got like my couple old MacBooks, and then this one, and was able to, without being an administrator, doing anything fancy, just go on each one and start a server, and then build it. It also does, built-in caching, so you can run it cached. It'll cache the object files. I did some performance testing. I think I fixed this one. Yeah, the configure doesn't take that long anymore. That was a bug. But fast build, it's on par with Ninja when you're doing regular builds. But if you actually do the distributed and the cache stuff, it can be a lot faster. There's a new modern CMake tutorial out, so that maybe help with the documentation. CMake's doing talking serif now, so it's easier to talk to tools and have better integration. So yeah, hey, you know, everything's looking bright. Here are some things that I'd like to see. CMake linting, this one actually we're working on. So the idea here is to let people know when they're doing sort of old bad things in CMake. And we're actually working on this feature right now. CMake is not a package manager. Turns out doing the build isn't enough. This is a thing I stole from Todd. Love that slide, Todd. You know, people have done external project, fetch content to get around this. People like to just say CMake. I've got this crazy idea I think that maybe could work. I don't know exactly how, but adding like a new step, CMake provision step, and that could run, you know, your package manager of choice, or maybe even run, you know, external package if you want, or Spack or Conan or whatever, and then you run the CMake configure, and then it's able to find everything. Spack develop is another thing. I think some combination of Spack develop plus CMake could create some really powerful tools. Let's say you're doing something and I want to develop libraries A, B, and C. I want to build or fetch the binaries for all the other dependencies. I want to get into a tight edit, compile, run debug loop on A, B, and C. And then, oh, I found out, I think the bug's really in F, you know, so I want to pull that into the development environment. And then edit, compile, run, and I want to do this, and I want to, you know, maybe drop it out. You know, I think we can get to a tool like this. I mean, we're going to have to work together, but I'm excited and think it's possible. So back to the errors of CMake. You know, we've got our Primordial flag soup, world domination. Hope you like target commands. CMake 4, I think, is going to be the era of interop and standardization. I hope you like JSON. Thanks, and you know, join the community if you're interested, and I'll take some questions. Or I probably won't, because we're out of time, right?
Any questions?
So, yeah, thank you, Bill. It's so cool to see, even in your dominant position, that you still give us a lot to look forward to in like a build system. So, so I think some projects take kind of a strong stance on this. I think Meson build is one of them, that your build system should not be Turing complete. It's kind of like a domain-specific language, because people do really weird and unholy things, and we get to see that as package, writers. So, and well, according to this AI answer, CMake is considered Turing complete, which I'm not saying it's a bad thing.
It does ray tracers.
You need flexibility. But I was kind of wondering, with the common package specification and these JSONs, like, is it now like very constrained in that sense? Like it's not a language. It's like a tight specification.
Well, the CPS is more of a outward product of the CMake build right now. So it's
oh, I see.
Generated. It's not input to CMake. Well, I mean, it can be input because it finds them, but you do the build and install, and instead of getting a .cmake file, you get a. But yeah, it does get rid of some of that.
Okay, because I'm also
Turing complete language in our package specifications.
Oh, I see. Okay, so so then I guess I would love to see the kind of like value that the CMake linter could do in raising the quality of people's CMake list files.
Cool, thanks.